So in this lesson, we are going to be solving rational functions. So actually looking at our restrictions and getting extraneous solutions, getting x equals answers. When we solve something, we get x equals or y equals something. Okay, so when we're solving and we're getting x equals 3 or x equals 4, what we're actually doing in this is solving to figure out what value, when I plug it back in for those x's, it's going to make both sides equivalent or equal to each other. Okay, so in this first one, when you just have two sets like this, you don't really need to have common denominators like what we're going to do in the next couple ones. Since the equal sign is in the center and we only have two fractions, the easiest thing to do with this one is actually to cross multiply. So if I cross multiply, it doesn't really matter what direction you go first. I'm going to take 4 times x, drop the equal sign in the center, and then I'm going to do 1 times the entire x minus 3. Okay, 1's not really going to do anything, but if that was a different number, just realize it is a binomial, so 2 terms. So just like when we're doing adding and subtracting, we always put those in parentheses. Same thing here. Okay, this one is really not going to do anything here. So I'm just going to write x minus 3, or you can have a little 1 if that helps. Now we're just going to solve. Okay, so when I solve this, I'm going to subtract the x to get 3x, divide by 3, and get -1. So here's what my answer is right now. The problem is I need to check to see if that is extraneous. So an extraneous solution means if I plug it back into my original, it's going to give me an answer that will give me an error in my calculator or an asymptote. So what we actually can do is find the restriction or the excluded values first, and it will automatically tell me if this is extraneous or not. So I'm going to look at all my bottoms, and anytime I see an x in the bottom, I'm going to set that set equal to 0. So I'm going to take that x minus 3, I'm going to set it equal to 0, so I can do my, we're going to call it restrictions. Okay, so I'm going to add 3. So I get x is equal to 3. That is a restriction. I want to restrict that value from being an answer, because if I have it as an answer, it will give me an asymptote or an error in my calculator. Okay, this -1 is not 1, so that means my answer is good. That means if I put that -1 in for both of the x's, and I simplified it, it would be equal to 1/4. It would make both those sides equivalent. Okay, the next one, I need common denominators to bring all that stuff together. So what we're going to talk about is the LCD, so the least common multiple, the least things they all have in common that we can multiply. So what do I want all my bottoms to become? What do I need them all to have? So I need them all to have a 5, and I need them all to have an x. So what we're going to do is we're going to take this whole set, and we're going to multiply by 5x. Okay, so when I multiply by 5x, what I'm going to do is distribute it to everything in the top. So this 5x times 5 is going to give me 25x. This 5x times 3 is going to give me a 15x. Okay, and this 5x times 2 is going to give me a 10x. And now I'm going to draw all my bottoms back in. Okay, and the reason that I chose that LCD was because now what's going to happen is all my bottoms are actually going to cancel. So these x's should go, these x's should go. I could technically take 15 divided by 5, and this is going to become a 3. Okay, let's go ahead and before I continue on, let's go ahead and do my restrictions before I forget again. So my restrictions, anytime I see an x, those are the exact same, so I don't have to do it twice. I set it equal to 0, I don't even have to solve. So I want to restrict the value of 0. So now if I finish solving this to see what my x is going to be, I'm going to subtract 25, divide by 3, and I'm going to get -5, which is fine because that's not one of my restrictions. Okay, so then my next one here, if you need to put this over 1 so you can actually see a fraction, I would go ahead and do that. Okay, so what do I need them all to have in the bottom? The least common denominator, okay? The least common multiple. So I need them all to have a single d and a d minus 2. Remember, they come as sets. Just because this d minus 2 has a d does not mean it contains that other d that's like on the left. So I need them all to have the set d and d minus 2. Notice I put it in parentheses. Okay, so we're going to weirdly send in this d times d minus 2. So this one here, easiest thing I can do is kind of put that 2 in front of it, this. So it becomes 2 times d minus 2. Okay, The 1 is not going to do anything, so if you want to put the 1 in front, you can. Otherwise, we really just have d times d minus 2, and the same with this one. If you want to have the 1s there, you're more than welcome to. Now fill in the bottoms. And let's go ahead and cancel. So these ones go, they're the same sets. These ones go, they're the same sets, and I don't really need all those ones I drew in. So if I have this left, this I just have that 1d is equal to 1d times d minus 2. So now we just got to think, how can I simplify? Let's go ahead and do our restrictions before I go any further. Probably good to kind of do this in the first step. So I have this one here, and I have this one here. Okay, I don't really have to solve this one, so I'm just going to solve this one. So I'm going to add 2 and get d is equal to 2. So my restrictions are, it can't be 0 and it can't be 2. So now if I solve this, I got to get rid of the parentheses. 2 times d is 2d. 2 times negative 2 is negative 4. 1d times d is d squared, because we're multiplying. 1d times negative 2 is negative 2d. All right, we want to go ahead and bring these together to be with their friends. Looks like this. I still don't have d is equal to something, but if I've got d squared, a d, and another value, what I'm going to end up doing is factoring or snowflaking, which means I need to bring it all to one side, because you cannot factor if it is not equal to 0. Okay, easiest way to do this is keeping that d squared positive if possible, so your front guy positive. So I'm going to bring everything to the right side so that I can factor this. So I'm going to subtract this 3d to be with his friend. And then I'm going to add 4 to the back end, since he doesn't really have a friend. Okay. Now I'm going to factor a times c in the top, b in the bottom, front guy. So multiplies to 4 adds to negative 5 is negative 4, negative 1. So d minus 4, d minus 1. So now when you solve them to get their values, this I would have to add 4, this I'd have to add 1. Now I'm going to look up there and double check to make sure my restrictions are okay, and they are. So I'm going to put a check mark by it to show that I checked to make sure that my restriction was not one of those numbers. So a lot of work for a very small problem. Okay, so I'm going to erase this here. So we have space for the next one. So I'm going to put this guy over 1 if you need to see it. Okay, I want you to pause the video and see if you can figure out what are you multiplying by this time. What do you want as the least common denominator here? What do you need every bottom to contain? Okay, every bottom should contain an n minus 1 and an n plus 3. So we're going to weirdly send in this huge thing. So when I send this n minus 1, n minus 3 into n, we're going to have n times n minus 1 times n plus 3. If I send it into the 1, it's not going to do anything, so I just really have to write n minus 1, n plus 3. And then I'm going to send it to the n squared here. So n squared times n minus 1 times n plus 3. Fill in our bottoms. All right, now I'm going to cancel. Those ones go. Those ones go. I don't really need the 1. So I'm going to rewrite what I have. So it looks like this. Now I got to think, how do I get rid of parentheses sets? So we have to be good at distributing. So this first set, the n on the outside is like a GCF. So you always work the 2 binomials first, just like if there was a 2 or a 3 sitting out there. It is the same process. Okay, so you're going to double rainbow this one here. Keep the n out there. So n times n gets me n squared. N times 3 is 3n. Negative 1 times n is negative 1n. Negative 1 times 3 is negative 3. I single rainbow this guy. N squared times n is n cubed, because now there are 3 n's total. 3 times n squared is 3n squared. All right, you could send the n in now if you wanted to. I'm going to get this together to make him a 2n to make it a little bit better. And now I'm going to send what is considered the GCF in. So n times n squared gets me n cubed. n times 2n gets me 2n squared. N times negative 3 is negative 3n. We still have this plus n minus 1 back here. And now we can start bringing some stuff together here. All right, because I got to solve. So let's go ahead and do our restrictions here. Again, it's probably better to do it at the beginning. I just keep forgetting. So I've got this one here. I've got that one there. So I would get n is equal to negative 3 and 1. All right, so solving this here, if I get my n cubes together, they're going away. So now I want to keep my n squared positive. So if I want to keep my n squared positive, the easiest thing to actually do is bring it all to the right because the bigger n squared is over there. So I'm going to do that. So I'm going to subtract this 2n squared over here. So, and bring this together. So negative 3n plus n is a negative 2n. And then when I subtract these, I get n squared. So then I can add my 2n. Add 1. Over here. And now we can snowflake. Multiplies the 1, adds the 2 is 1 and 1. Only really need to solve 1 because they're the same. So n is equal to negative 1. So now I'm going to go up and check, is that one of my restrictions? It is not. So I'm going to circle it and I'm going to put a check mark next to it to show that I've checked my restriction. Okay. The next one here, we can go ahead and cross multiply because there are only 2 sets. So I'm going to send this way. The 1 isn't going to do anything. So I'm going to write out m squared plus m minus 2. So if I send this in, I've got 2m squared minus 2. I'm going to look here. I need to figure out my restrictions. So I have m squared minus 1 is equal to 0, and I have m squared plus m minus 2 is equal to 0. Okay, so the top one, you can snowflake both of them. Okay, you can also do square root property for the top one, and it will actually be faster than snowflaking it. So if I did square root property, I would add 1 and square root. If you wanted to snowflake it, you would get negative 1, 0, and m, so 1 and negative 1. So when you solve, you would get a 1 and a negative 1. This other one, you would have to snowflake. So I would get a 2 and a negative 1. So when I solved it, m plus 2, m minus 1, so I'd end up getting a negative 2 and a positive 1. So we had a lot of restrictions on this one. All right, so keep going here. Get my m squared to be together, so I'm going to bring it over to the bigger side. So I've got m squared minus 2 is equal to m minus 2. So I'm going to bring my m over and bring my 2 over. Alright, those actually cancel both sides. So the weird part about this is when we're going through, we generally still go through, is there GCF, is my front guy positive, and can I snowflake? Okay, so in this one, there is a GCF of m. So if I take that m out, I have m minus 1 left. So when I solve them, I get 0 and 1. So do all of those work? 1 does not. So this is my extraneous solution. My extra solution that doesn't work. Okay, this one is the only one that I can actually have that will work. Okay, so my next one here, I would pause the video, see if you can start running through these on your own. See what step you kind of stop at. Okay, so figure out what you need to multiply by, try to send it in, try to cancel, and then try to solve. Okay, my restrictions, I got x minus 3, I've got x plus 5, so I get 3, negative 5. So when I multiply by is minus 3, x plus 5. So send it in. It doesn't do anything to the 1. Doesn't do anything to that one. But it will do something to this one. So I still have the x plus 1, and I'm adding on x minus 3x plus 5. Draw on their bottoms, because you want things to cancel. If things don't cancel, it gets ugly. All right, x plus 5s go, x minus 3s go, x minus 3 goes. So I have x plus 5 plus x minus 3. I've still got x plus 1, x plus 5. All right, so I'm going to do two kind of steps here. I'm going to double rainbow my right side to get rid of those parentheses, and I'm going to combine my left side to make it a little bit smaller. So x plus x gets me 2x. 5 minus 3 is 2. This gets me x squared plus 5x minus 1x plus 5. Okay, which I can make this a 6x if I need to. So now I'm going to bring it all to the right because I'm going to end up factoring. So I'm going to bring my 2x over to be with this 6x. Oops, 4x. And I'm also going to bring that 2 to be with the 5. Okay, so when I snowflake A times B, B, front guy, so 3 and 1. So I would get negative 3, negative 1. So let's check to see if we're good with those. I am. Both of them are not restrictions. Okay, so the next 4 questions, what I would do is pause the video. I am not going to talk through it, but I will show my work for them. So go ahead and for the next set of questions, I kind of wanting you to try it on your own. There is going to, 7's going to be a little harder. So maybe save it for 8, 9, and 10. So if we look at 7, I can't tell what they actually share in the bottom. So I'm going to have to do some things here. First off, what I want to do is I'm going to bump that negative sign up. And now I'm going to take a look at those 2 bottoms on the right. So if I snowflake x squared plus 3x minus 4, I get negative 4, 3, x, 4, negative 1. So I'm going to rewrite him x plus 4, x minus 1. The issue with this guy is if I reflip him, he is now negative x plus 1. So I'm going to take that negative out because now he's actually going to appear like one of them that I want. So if I rewrite my whole problem here, it's looking like this with simplified bottoms. So one thing that you can do to make this a little bit easier is because these 2 guys are negative, I can actually make them a big positive. 2 negatives make a positive. So I can actually cancel these guys out and make them plus signs and not even really have to worry about them because 2 negatives make a positive. Okay, so if I rewrote it, I don't really need the 1 in the bottom. He's now a positive 1 over x minus 1. That's going to be a lot easier. If you don't do that, you're just going to have to multiply the whole set by negative 1, which is totally fine. So now I'm going to take this whole set and multiply times x plus 4, x minus 1. And here's the part where I think you should be able to pause the video, send that guy in, start crossing things out and solving for me. Don't forget to do your restrictions. So for the next sets of problems, pause the video, try it on your own, and see what you can get. All right, so this one ended up where we actually had no solution. So when I went through my whole process, my x's canceled. For mine, negative 1 does not equal 6. So if you get 2 things that don't equal each other, it is going to be a no solution. If I have 5 equals 5, then I'd have infinitely many solutions. Just like when we do systems with normal graphs, that means I actually have multiple things that would work if it's infinitely many. No solution means there is not a single x value that would make those sides equivalent. Okay, your restrictions, which you can't see on mine, your restrictions would be negative 4 and a positive 1. Okay, so go ahead and pause the video and try to set up your number 8. I'm going to go ahead and write out all of number 8. All right, so here's my number 8. So I multiplied by b plus 2, b minus 2. You had to double rainbow the left side and the right side. Okay, ended up where when I subtracted, my b squared canceled. So then all I had to do was solve for b. So I got my b is equal to 14, which is not a restriction. Okay, for the next one, number 9, you're going to have to make sure you can see what they share in the bottom. So I'm going to snowflake x squared minus 9 and then bump that negative sign up to be with its buddies on the top. And then we're going to start to multiply. All right, so here's my number 9. My restrictions were 3 and negative 3. I sent in an x plus 3, x minus 3, did all my canceling. Okay, after I did all my canceling, I knew I had a single rainbow one on the left side, single rainbow one on the right side. Then I just started combining my terms. And I wanted to keep x squared positive, so I brought everything to the left side. I went ahead and snowflaked and solved my 2 snowflakes. When I solved my 2 snowflakes, the x is equal to negative 3 was one of my restrictions. So I crossed them out. I said u is extraneous. Okay, and then my other one was going to be my true answer. So 3/2 or 1.5. All right, so go ahead and pause the video and go ahead and try the last one. All right, so I'm not going to show you what happened with this. So when I got to my snowflake, you would actually have to use quadratic formula to solve this one because it is not going to snowflake correctly. So just realize that there are possibilities where you technically could quadratic formula. I will never give you one in the test, but there is a possibility of that being able to happen, that occurrence where you could use quadratic formula to solve these, or snowflake does not happen.